Now, what is z value? Z nothing but y raised to 1 by 2. So here y raised to 1 by 2 multiplied by integrating factor, that is 1 minus x square raised to minus 1 upon 4 and q. Let us solve one more example. Solve the differential equation dy by dx plus xy upon 1 minus x square plus 3x root y. So what do you do now? Dy by dx. Hello friends, once again I am going to teach you something special in mathematics, that is the Bernoulli's equation. I hope you will enjoy the topic and stay with me till end of the video. So let's start today's topic, that is Bernoulli's equation. Today let us talk about Bernoulli's equation. Example, dy by dx plus py equals to q into y raised to n. This type of the equation is called as a Bernoulli's equation. And this type of equation can be easily converted to linear form, linear differential equations. So first of all, let us understand what is p and q. P is a function of x. Q is also function of x. For example, dy by dx plus 1 upon xy equals to x cube y raised to 5. So what is p value? P equals to 1 upon x. What is q value? Q value equals to x raised to 3. And here is the y raised to n and here is the y raised to 5. Implies y raised to n equals to y raised to 5. So this is the Bernoulli's equation. Now this equation can be converted into linear form, that is a linear differential equation. In today's class, in today's video, we are going to learn how to solve the Bernoulli's equation. Now let us understand how to solve Bernoulli's equation. Here I have taken, left side I have taken one theoretical part and the right side I have taken one practical example. Whenever such equations are given, you must see what is at the RHS. What is the, here is the RHS, y raised to n is there. Don't see the q value, see y raised to n. So dividing both sides by step 1. Step 1, dividing both sides by y raised to n. So we get here dy by dx plus py upon y raised to n equals to q into y raised to n upon y raised to n. This becomes 1 upon y raised to n dy by dx plus p into y upon y raised to n equals to q. This can be written as y raised to minus n dy by dx plus p into y raised to 1 minus n equals to q. Now, in this practical example, what is y raised to n? Y raised to 4. Therefore, dividing both sides by y raised to 4. So, dy by dx plus y upon x divided by y raised to 4 equals to x cube y raised to 4 upon y raised to 4. This and this cut down. This becomes 1 upon y raised to 4 dy by dx plus y upon x into y upon y raised to 4, 1 upon y raised to 4 equals to x cube. This can be written as y raised to minus 4 dy by dx plus 1 upon x into y raised to minus 3 equals to x cube. After that, let y raised to 1 minus n equals to z. Here, let y raised to minus 3 equals to z. Differentiating with respect to x. Here also differentiating with respect to x. So that is differentiation of y raised to 1 minus n with respect to x equals to dz by dx. Here differentiation of y raised to minus 3 with respect to x equal to dz by dx. Now this is equivalent to 1 minus n y raised to 1 minus n minus 1 into dy by dx equals to dz by dx. So here minus 3 into y raised to minus 3 minus 1 dy by dx equals to dz by dx. So this is 1 minus n y raised to minus 1 plus 1 get cancelled, y raised to minus n into dy by dx equals to dz by dx. This is minus 3 y raised to minus 4 dy by dx equals to dz by dx. So we will continue this one, and so we get here y raised to minus n dy by dx equals to 1 upon n minus 1 dz by dx. This becomes y raised to minus 4 dy by dx equals to minus 1 upon 3. Here dy by dx and here is the dz by dx. So now we will be using this relationship. So step 1 is over. Now y raised to minus n dy by dx, this will be deleted, and in the place of this one I am going to write this one, that is 1 upon 1 minus n dz by dx, and in place of y raised to 1 minus n I am going to write z, that is in place of y raised to minus 4 dy by dx, in place of this I am going to write this one, and in place of y raised to minus 3 I am going to write this one. Therefore above equation gets converted to 1 upon 1 minus n dz by dx plus pz equals to q, that is minus 1 upon 3 dz by dx plus 1 upon x. In place of y raised to minus 3 we can write z and x cube as it is. After that, here dz by dx got multiplied to 1 upon 1 minus n. You just throw it out. How to throw it out? This way. Dz by dx plus 1 minus n pz equals to q into 1 minus n. So we made dz by dx free from any multiplier. Here multiplier in the RHS side, the dz by dx is multiplier of 1 upon minus 1 upon 3. So you have to throw it out. How to throw that? So here is the minus is also there. So taking the minus common and the 3 will go there. So it becomes dz by dx plus 3 upon x z equals to 3x cube, and this minus will go that side. So it becomes minus 3x cube. Now it has been converted to linear differential equation. Now it is what type of form? It is a form of linear differential equation. Here by mistake I have not written minus. When you take the minus common, here minus will come. Okay. So now we have to find out the integrating factor. So integrating factor is given by e raised to integration of p dx. So that is integration of what is p value? P value whatever it may be. So here I can find out practically integrating factor, integration of what is the p value? P value minus 3 upon x with respect to x, that is equals to minus 3 log x, that is equals to e raised to log x raised to minus 3 equals to x raised to minus 3. Therefore integrating factor equals to x raised to minus 3. After that, solution. What is the solution? Solution is nothing but z into integrating factor equals to integration of q into integrating factor with respect to x plus c. Now z as it is, and integrating factor is x raised to minus 3. What is q? Q nothing but minus 3 x cube multiplied by integrating factor, that is x raised to minus 3 with respect to x plus c. Now what was the z value? Z value nothing but y raised to minus 3. So in place of z, we will be putting y raised to minus 3. So y raised to minus 3 into x raised to minus 3 equals to minus 3 taken common, x raised to 3 into x raised to minus 3 with respect to x plus c. So this becomes 1 upon x cube into y cube equals to minus 3 1 dx plus c, integration of 1 dx plus c. So that is equals to 1 upon x cube y cube minus 3x plus c. Taking this to the right side, so 1 equals to 3x into x cube y cube plus c into x cube y cube implies 3x raised to 4 y cube plus c x cube y cube equals to 1 is required solution. So this way we solve Bernoulli's differential equation. Let us solve one more example. Solve the differential equation dy by dx plus xy upon 1 minus x square plus 3x root y. So what do you do now? Dy by dx plus x into 1 minus x upon 1 minus x square into y equals to 3x, and root y can be written as y raised to 1 upon 2. Now this is in the Bernoulli's form. So now we have to first convert to into linear differential equation. For that, dividing both sides by y raised to 1 upon 2. Dividing both sides by y raised to 1 upon 2. Therefore, we get dy by dx x 1 minus x square into y divided by y raised to 1 upon 2 equals to 3x y raised to 1 upon 2 divided by y raised to 1 upon 2. This can be written as 1 upon y raised to 1 upon 2 dy by dx plus x upon 1 minus x square into y upon y raised to 1 by 2. This in RHS they get cancelled, equals to 3x. After that, this can be written as y raised to minus 1 by 2 dy by dx plus x upon 1 minus x square y raised to 1 minus 1 by 2 equals to 3x. So this can be written as y raised to minus 1 by 2 dy by dx plus x upon 1 minus x square y raised to 1 upon 2 equals to 3x. Now let y raised to 1 upon 2 equals to z, differentiating with respect to x. So 1 upon 2 y raised to 1 by 2 minus 1 dy by dx equals to dz by dx, that is 1 upon 2 y raised to minus 1 by 2 dy by dx equals to dz by dx. Therefore, y raised to minus 1 by 2 dy by dx equals to 2 into dz by dx. So now here in this part I can write 2 into dz by dx plus, and y raised to 1 by 2 nothing but z, x upon 1 minus x square as it is. Here is the z equals to 3x. Now dz by dx having the multiplier, so free, we have to make it free from any multiplier. So, dividing both sides by 2, So we get 2 into, I'm doing all the steps so that everybody must understand. But if you think that there are some steps are unwanted, then you can directly go for. But it is my job to do all the steps to understand, to make everybody understand. So x upon 1 minus x square, and 2 will come here. Here is the z equals to 3 upon 2. 2 to get cancelled. So what do you get now? You will get here dz by dx plus x upon 2 into 1 minus x square, z equals to 3 by 2 x. Now it is a linear differential equation where p is the x upon 2 into 1 minus x square, and q equals to 3 by 2 x. What is the next step? The next step is to find out integrating factor. So integrating factor equals to e raised to integration of p dx, and that is equals to e raised to, what is the p value? P value nothing but x upon 2 into 1 minus x square with respect to x. Now this integration we will do in the rough work. To 1 minus x square with respect to x, and 1 by 2 taken outside, x upon 1 minus x square with respect to x. Let 1 minus x square equals to t. So minus 2x dx equals to dt. This is the substitution method. And if your integration is not strong enough, and so if you want to learn it substitution method, then go to my playlist. You will find the integration by substitution method. You will find lot of chapters on integration, like substitution method, basic integration, exponential, everything you will find on my playlist. Go and visit it. And also don't forget to give me feedback how you find my integration. So here is the x dx equals to minus 1 upon 2 dt. After that 1 by 2 is outside, integration 1 upon t and minus 1 by 2 dt, that is minus 1 upon 4 and integration of 1 upon t dt, that is minus 1 upon 4 log of modulus t. Therefore this becomes e raised to minus 1 upon 4 log of modulus t. T nothing but 1 minus x square. So this is equals to e raised to log of 1 minus x square raised to minus 1 upon 4, and this is equal to 1 minus x square raised to minus 1 upon 4. So this becomes the integrating factor. After that, the solution is z into integrating factor equals to integration of q multiplied by integrating factor dx plus c. What is z value? Now, what is z value? Z nothing but y raised to 1 by 2. So here y raised to 1 by 2 multiplied by integrating factor, that is 1 minus x square raised to minus 1 upon 4, and q nothing but 3 upon 2 into x multiplied by integrating factor, that is 1 minus x square raised to 1 upon 4 dx plus c. So that is equals to root y divided by 1 minus x square raised to 1 upon 4, 3 by 2 taken outside, integration of x divided by 1 minus x square whole raised to 1 upon 4 dx plus c. That is equals to root y upon 1 minus x square raised to 1 upon 4, 3 by 2. Here we can go for substitution method. So for substitution method, let 1 minus x square equals to t. So minus 2x dx equals to dt. Therefore x dx equals to minus 1 by 2 dt. Therefore it becomes root y upon fourth root of 1 minus x square equals to 3 by 2 integration of 1 upon t raised to 1 upon 4 and minus 1 by 2 dt plus c. So root y upon fourth root of 3 by 2 and minus 1 by 2 taken outside and integration of t raised to minus 1 upon 4 dt plus c, that is equals to root y upon fourth root of 1 minus x square equals to minus 3 upon 4 and integration of t raised to minus 1 by 4 nothing but minus 1 by 4 plus 1 and minus 1 by 4 plus 1 plus c. Now we can further simplify that part. So that is root y upon 1 minus fourth root of 1 minus x square equals to minus 3 upon 4 into 4 upon 3 into t raised to 3 upon 4 plus c. 3 gone and 4 also gone. So root y equals to 1 minus x square raised to 1 upon 4 into, what is the t value? T value nothing but 1 minus x square. So 1 minus x square raised to 3 upon 4 plus c. So root y equals to 1 minus x square whole raised to 1 upon 4 plus 3 upon 4 plus c. So root y equals to 1 minus x square raised to 4 upon 4 plus c, that is root y equals to 1 minus x square. Here also we have to multiply 1 minus x square raised to 1 upon 4, 1 minus x square raised to 1 upon 4. I forgot to write down that. Now I am writing. So plus 1 minus x square raised to 1 upon 4 into c. This is final solution. So we found that the solving the Bernoulli differential equation quite easy. There is not at all difficulty we'll find out. Only that you have to be good at integration and good at the linear differential equations. Only 2 to 3 steps new we found here. That is supposition of y raised to n and let y raised to minus n equals to z and doing the derivative converting into linear differential equation. So these are the 2 to 3 steps are new. Otherwise the solving the Bernoulli differential equation is quite easy. I hope even you found the solving the Bernoulli differential equation quite simple. If you have still some doubt in your mind, please communicate with me on my email address provided in the description box. Meet you again with another topic. Till then, wish you good luck, all the best. Before saying goodbye to you, I would like to request you like, share and subscribe the channel so that you will be always updated on the new videos as soon as they get published. Bye bye. See you. Meet you again with another topic. Bye bye.